The way two melodies move in relation to each other is called contrapuntal motion, and it's an essential concept in music theory. There are four types: parallel, similar, contrary, and oblique. Each creates a different effect, and understanding the four types is the key to unlocking how to harmonize. Let's take a closer look at each type. Let's start with the simplest type of motion. Here, the voices are moving in the same direction, and the distance between them is the same. They're always a third apart. This is called parallel motion, and it's the most common type because it's easy to write and it effortlessly sounds good. We use the interval between them to describe what's happening. So these are parallel thirds. You can also write parallel sixths. And in three voices, parallel thirds and sixths at the same time. This is actually an old technique called phoberdon, and stay tuned for a video dedicated to it because it's really interesting. Composers use parallel thirds and sixths everywhere, and occasionally use parallel intervals of other types. The band the B-52s, part of their signature sound is parallel fourths. But let's take a look at parallel fifths for a minute. Hopefully the effect here sounded very different to you, perhaps more hollow or clunkier. Parallel fifths were one of the earliest harmony techniques in the Middle Ages, but as Western music developed, composers decided this sound was out of date, old-fashioned, and more importantly, boring. It can also be confusing to the ear because the perfect fifth is a stable interval, and if a melody consists entirely of stable intervals, it's hard to tell which one is supposed to be the truly stable one. Parallel fifths eventually were considered to be one of the biggest mistakes you can make in Western harmony. And if you study classical music, you need to understand this concept. I personally love parallel fifths, and if you're a modern composer, don't think that you're not allowed to use them. In fact, parallel fifths are exactly what power chords are on the guitar. But if you're going to study music theory, you do need to understand when and why composers do or don't use parallel fifths. You can find examples of parallel motion, especially parallel thirds, in nearly every genre, from classical to jazz to pop. Let's take a quick look at an excerpt from Mozart's Overture to the Marriage of Figaro, where we find parallel thirds in the harmony, the melody, and in the quick runs. Parallel motion is simple, but it makes the voices sound almost identical. They're doing the same thing and not moving independently, so it may become monotonous or predictable over time. Now let's look at something slightly different. These melodies are also moving in the same direction, but notice that the intervals are different. We have a sixth, a fifth, a fourth, and a third. This is called similar motion. Both voices are moving in the same direction, but the intervals don't remain constant. I like to think of it as a lot like parallel motion, but the intervals are sort of compressed or opened up as needed to fit the harmony. Now for a bit of instrumental history. In the Baroque and classical periods, trumpets and horns didn't have valves, so they could only play the notes in the harmonic series. They could play all the notes of the 1 chord and 3 of the 4 notes of the 5/7 chord. So composers often tried to give them melodies that fit into these harmonies. The brass instruments were frequently used in pairs, so the brass lines in this era relied heavily on similar motion, using notes that they could play that fit into these harmonies. Listen to the famous Ode to Joy melody by Beethoven in his Ninth Symphony when the horns and trumpets enter. This entire melody is harmonized in 2 parts just using the notes that the valveless brass can play. You'll see closer intervals of thirds as they go higher in register, and larger intervals of fifths and sixths as they go lower. But just like parallel motion, it's simple and it can get old quickly, which takes us to the next type. These melodies are moving in opposite directions. One is going up, one is going down. This is called contrary motion, and it's the ultimate in melodic independence. They're doing totally different things, not relying on each other at all. They get closer or further apart as they move towards or away from each other. Composers love doing this because it sounds cool, but it's a lot harder to maintain for long periods and have all of the notes work together. I love the effect when composers make the highest and lowest voices of a chord progression move in contrary motion, so you can hear the chords sort of expanding and contracting. Listen to this brass chorale at the end of Mathis der Mahler's Symphony by Hindemith. The first trumpet and tuba move nearly in complete contrary motion, with the rest of the brass filling in the chords in between them. And the final type of motion is another way to make the voices sound independent. One voice is moving and the other is not. If they're not moving at the same time, they're independent. This is called oblique motion. This can take the form of one voice holding out a long tone or repeating the same pitch while the other one does something interesting melodically against it, like in this example. Or it can involve the two voices taking turns, highlighting the moving voice each time. One of the coolest ways that composers use oblique motion is in suspensions, where one note is held into a new harmony where it no longer fits, and then it moves to fit into it. One of my favorite long chains of suspensions is the B minor prelude from Bach's Well-Tempered Clavier. Check out all these suspensions in the upper voices. Here it is on organ, so you can really hear those notes hold over into each other, clash, and then relax. So why does all this matter? Well, when you're writing two melodies together, the goal isn't just to avoid mistakes. It's to craft lines that are intentionally designed to sound good both alone and together. Using a variety of motions helps keep things unexpected and interesting. Let's take a look at another example that shows the simultaneous use of two of these types of motion. It's a short woodwind passage from the second movement of Beethoven's Fifth Symphony. Before I explain it, see if you can figure out what two types he's using and how he's doing it. So what's happening? The top two voices, the flute and oboe, are moving together in parallel thirds. The bottom two voices, two clarinets, are also moving together in parallel thirds. But those two groups are moving in contrary motion to each other the whole time. So we have parallel motion within the two pairs and contrary motion between those two pairs. This is not easy to do and make sound good. Listen again with the motion highlighted. So when you're composing or working through a theory exercise, always think about how your voices interact. Are you relying too much on parallel motion? Could you introduce more contrary motion? Or are you trying so hard to use contrary motion that the result just sounds awkward? These small decisions can make a big difference in the overall texture of your music. And if you're studying part writing, there are rules for certain intervals using certain types of motion. For instance, we avoid parallel octaves, fifths, and unisons, but we use lots of parallel thirds and sixths, and as much contrary and oblique motion as possible. That's it for today's dive into contrapuntal motion. I'm Dr. Fromm. If you found this video helpful, don't forget to like and subscribe, and stay tuned for more music theory tips.